we learned that our systems could either have one solution where they cross in one place and share one point, or they could overlap and share infinitely many points and have infinite solutions, or they could never, whoops, that wasn't very good. They could never ever cross because the lines are parallel and we have no solutions, right? Okay. So today we are going to, instead of solving graphically, we're going to solve systems by a method called substitution. Oh. And this is an algebraic method. We're basically going to turn one of these crazy looking systems into a really easy Unit 1 problem that we could solve at the beginning of the year. Okay, so we need to remember that a solution to a system of equations is the set of all the points that make all of our equations in the system true. Okay, it's got to make them all true, not just some. Okay, it's got to be making all the equations true to be a solution. Got to satisfy them all. Okay. So we're going to test some solutions like we have tested them since the beginning of the year by substituting them in and seeing if they make our equations true. But it's not enough to just test them in one equation. We now have to test them in both. So I'm going to number them. Here's equation 1 and here's equation 2. Okay, here's my x, here's my y. So I want to know if I plug in the 4 and the 5 for x and y, is 4 plus 5 equal to 9? Yes. Yes. Okay, so it makes one true. So far, so good. Now we have to test them in the other one. All right, watch out because this time the y comes first. Is 5 equal to 4 times 4 minus 1? Well, 4 times 4 is 16, minus 1, that's 15. So 5 is not, so this is not a solution. So it only took one no to make it not a solution. It doesn't matter that the other one was a yes. It has to make them both true or it doesn't work at all. It's all or nothing. Okay, now we're going to test B. All right, in equation 1, is 2 plus 7 equal to 9? Yes. Okay, that was a nice one. Here's my x, here's my y. Is 7 equal to 4 times 2 minus 1? 8 minus 1 is 7. 7 equals 7, I heard yes, so this is a solution. So yes, it's a solution. So it worked for both. I forgot to label these. I meant to label it. This is 1. This was 2. This was 1. This was 2. Okay, the more you label your work, the easier it will be for me to grade, and the better mood I will be in, and the more points I will likely award you. If you make me work too hard to figure out what you were doing, sometimes I just have to cut my losses, you know what I mean? Okay, make it easy for whoever who's grading your paper. All right, so now we're going to, here, let's think about this. If they ask you about a specific point, whether or not it's a solution, it's really easy to just plug it in and test it, right? But if we were actually trying to solve a system and we were testing points individually, it would take forever because there are literally infinitely many points to test. You see that that's not an efficient way to solve a system? Yes. Like I'm not just going to pick random points and plug them in. It doesn't work very good. So I'm going to show you how to systematically solve systems using a method called substitution. The idea is that if we can get rid of one of the variables, we can solve a one variable equation like we did back in Unit 1, and life is good because we already know how to do that. So here's how it works. We have to isolate either an x or a y. Now, there's a strategy to picking what to isolate. You kind of want to isolate the weakest member of the herd, okay? So you want to pick a variable that has a coefficient of 1. So do you see that I don't want to pick this one? Because it's got a coefficient of 2, negative 2. And if I try to get that alone, I'd be dividing everything by a negative 2 and I'd have ugly fractions. Don't pick that one. That is the way of nightmare and terror, okay? So you want to try to pick one that already has a coefficient of 1 if possible. So you could pick either that x, that y, or that y. Which one do you pick?
That x.
That x. All right, I like it. So we're going to pick this x. So we got to get rid of the y, so I'm going to subtract it away from both sides. So I'm going to rewrite equation 1 as x equals 5 minus y, because I subtracted away the y. Now I'm going to sort of put part of equation 1 into equation 2 and solve them both together. So this is how it works. I'm going to replace the x with an equivalent expression in my other equation. You see how this is equal to x right there? Okay, and then I have this x just sitting there. I'm going to substitute that whole thing in right there. The whole thing's going to go in. So make sure you use parentheses or brackets. So it'll be y minus 2 times my whole x equals negative 1. Now my x is 5 minus y. You see what just happened? Now I kind of made a hybrid equation that has the two equations combined, but there's only one variable in it. I got rid of all the x's. And we know how to solve this, right? So now we're going to solve for y. So how do we get rid of these parentheses? Yeah, just be careful because you're distributing a negative 2. So that'll be y minus 10. What's a negative times a negative? Plus 2y equals negative 1. Now I have a y and a 2y. Combine like terms, and I have 3y minus 10 equals negative 1. Add over my 10. And I get 3y is 9. Last step, do it in your head. Divide by 3.
Y equals 3.
Correct. Okay, we found y, but remember, in Unit 8, we're solving for points. Okay, we want x's and y's, so we still have to find an x. So we're going to substitute and solve again, this time for the other variable. So we get to take our pick. Which equation looks the friendliest, easiest? 1 or 2? 1. Okay, mathematically it doesn't matter. You just get to choose your own adventure. They will both work, but sometimes one is friendlier looking than the other, okay? So I'm picking equation 1 that says x plus y has to equal 5. I just found what y is. It's 3. What plus 3 is 5? Yeah. That was a really good pick. So when you write your point, make sure you always put the x first. Just because I found the y first doesn't mean I write it first. I always write the x first in the point. So it goes 2, 3. Here's the x, here's the y. This is my final answer. That's not too bad. Yep. Really quick. Yep, and 2 plus 3 is 5. Actually, if you plug in 2 and 3 in the second equation, it will make that one true also. That's a good way to check your work. All right, ready? Let's flip. All right, so we are looking to isolate a variable whose coefficient is 1. Okay, so you can pick either the y on the top or the x in the second equation. Can we isolate a y this time? I want to show you can do either. Okay. So I'm going to isolate y. So I'm going to subtract away the 2x, and I get y equals 9 minus 2x. Now in my second equation, I have a y that I can substitute 9 minus 2x for. So I'm going to replace my y with an equivalent expression. So that looks like x plus 4 times 9 minus 2x equals 8. Now I get to solve for x this time. How do we get rid of them parentheses? What? Yeah, distribute. I'm distributing a positive 4. So x plus 36 is that minus 8x equals 8. Combine my like terms. I have a positive x and 8 negative x's.
7.
What kind of 7x? Negative 7x. So I've got negative 7x, a positive 36 equal to 8. Subtract away my 36. Negative 20 what? Okay, thank you. Can you do this in your heads? Negative divided by a negative is going to make a positive. Good. Positive 4. Okay, so last but not least, we have to substitute and solve again. So which one looks friendliest? Equation 1 or 2? 2? All right, well, what did we do last time? 1? I'm going to do 2 this time just to show you that you can do either. All right, so this says x plus 4y equals 8. And what do we know that x is? 4. Okay, subtract away the 4 from both sides, and I get 4y equals 4. Divide both sides by 4, and I get y is 1. So my point is 4, 1. So far I've just had one solution and one solution. Guys, we're making good time. Okay, let's do another one. Oops, wrong way. All right, we're going to go a little faster on this one. This time we don't have many options for what to isolate that would be easy. Yeah, the y in the first equation, right? All right, this is our guy right there. There's the weakest link. So we're going to add 2x to both sides, and we get y equals 2x plus 4. Okay. Here's a y that I can substitute in for. Now I've got 2x minus my whole y equals 9. My whole y is 2x plus 4. I'm replacing the whole thing. Now be careful because we don't have a 2 to distribute here. What are we distributing?
A negative sign.
A negative sign, which is like distributing a negative 1. So I have 2x minus 2x minus 4 is 9. see happens to my 2x and my negative 2x? What? Yeah, they cancel. So, here's the big brain question. In your vast algebraic experience, does negative 4 ever equal 9?
No.
Correct. So, is this, what kind of situation is this?
No
One
solutions.
solution? What?
No solution.
No solutions. Okay, so we have parallel lines that never ever touch. No solution. Now you kind of maybe understand why we do the graphing first, so that you have a mental image of what's happening algebraically. Cool. All right, perfect. Let's do 3 more. Oh, 2 more, sorry. Okay, what are we going to isolate?
The Y.
The y again. Okay, so let's say that y equals 3x minus 4. And this is equal to y, so I can plug it in right there. Substitute it in. That's how the method gets its name, right? It's the substitution method because we substitute something in. So we get 3x minus our whole y equals 4. Thank you. Okay, that's fair. Okay, just like we did on the previous problem, we are distributing a negative 1. So I get 3x minus 3x plus 4 equals 4. Watch your signs. It gets tricky. A negative always changes the signs to their opposites. The 3x's cancel because they're opposite in sign. Okay, I can. Does that really change anything? Isn't 0 always 0? Isn't 4 always 4? Okay, so if this was no solution, what's this one? Infinite solutions. So this is a situation where we have the same line twice. It's overlapping everywhere.
So what would it look like if we only had one solution now?
They just intersect in one place, like when 2 streets cross. So if we go here, I'll show you. Can I show you on this next one?
Yeah.
Okay. Okay, really quick. If you were to rearrange this for y, you would get y equals negative x plus 7. If we put these in the calculator, you'll see that they just cross once. Okay, we're going to find that out in 2 seconds. Okay. All right, so we've already got a y alone. Do you see that? This one is already set up for substitution. We don't even have to do step 1. Okay? So I can just automatically go to step 2 where I replace y with this equivalent expression. So I have x plus the whole thing equals 7. So that would be 2x plus 1. Now, how do I distribute a plus? Does it change anything? No, I don't even need those parentheses anymore. So I can just combine my like terms. X and 2x make 3x. Subtract away the 1. 3x equals 6. Do the last step in your head. X is 2. So now I have to find the y. Which looks easier? 1 or 2? 2? I agree. Okay, so let's pick equation 2. X plus y has to equal 7. Oops. And we already know what x is. X is 2. Yes! Okay, so 2 plus y is 7, so we subtract away the 2 and we get y is 5. Okay, so we know it's 2, 5. Here's my x, here's my y. The last part says I have to find the value of this expression using this x and this y. So I know that my x is 2 and my y is 5. So 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. That's it. Thank you.